Mary Claire. All right. I do have, take out your practice test. This is the answer key. You might want to write the word key on it. I mean, the answers on it should give that away, but it should be a little easier to know from a distance. I'd like you to take a few minutes, compare this to your practice test from yesterday, and see if you have any last minute questions. There are two things we're after. One is so you know how to do the problems. And two is you know how to do all of the problems within the time limit. So if there's a question that bogs you down where it took like 45 minutes to do a problem, that's one we need to go over. Questions? The blank? Yeah. Yes. Does anybody else not have a copy of the original practice test that I gave out yesterday? I think that's all right. We're going to take a minute or two, and we'll do attendance, and then I'll be up there and spending an entire hour going through whatever you like. Okay, go ahead and keep looking over them, but what would you like to see dissected? So, questions? Any of those that when you were doing it yesterday, you got stuck? I mean, it's a very similar form to the previous problem, so if you get stuck on the previous version, ask about it. Because remember, you will have a normal class period without assistance from other people to do this on your own. So if there's anything that's still nebulous, ask the question about it. Yeah, go.
Number
20. Okay. Identify the vertex, blah, blah, blah. Y equals negative x squared plus 6x minus 8. And they want the vertex, the axis of symmetry, the x-intercepts, and the y-intercept. And then they want you to graph it. Now I will be giving you an optional extra method today, which we're going to cover more next chapter, but I'll give it to you early just in case somebody likes it. I hesitate to give it to you as a formal method right now because I don't want people to have too many formulas to stagger under. But first and foremost, what form is this? There are 3 forms of a quadratic that we've been playing with. What's this? Let's see. Actually, Jack, go. That is standard form. If it's standard form, what is A, what's B, and what's C? Sam, what's A? Negative 1. What's B? 6. And what's C? Good. Negative 8. Clear? If it's in standard form, they do not hand you the vertex on a silver platter. There are 2 techniques we know that allow you to get this stuff. One is if you think you can get it into vertex form, and the other is if you think you can get it into x-intercept form. The standard form by itself is not very useful. By the way, it is useful for one thing. Does anybody remember the one thing in standard form that it just sort of gives you? Just, yeah. What do you think? One of these 5 things, standard form is very good for. The y-intercept. Standard form is incredibly good for line of y.
Plug in 0.
Yeah. You plug in x equals 0, what would you get?
Negative 8.
Yeah. Whatever the last number is there, forgive me. This is the y-intercept. So that's one good thing that standard form is good for. So you can find the y-intercept, it's negative 8. So you're 1/5 of the way done, so to speak. That's about all that standard form is good for. Would you recommend changing it to vertex form or changing it to x-intercept form? And both can be done. And neither of them are horrendously hard at this problem. But whoever wants to volunteer, I'll let you pick. Okay, go. Vertex form. How do you change standard form to vertex form? Complete the square. Correct. I'm going to set it up. What's step one of vertex? What's step one of completing the square? Right. Set it equal to 0. So it's negative 1x squared plus 6x plus negative 8 equals 0. Is that okay? Remember, there are 5 steps to complete the square. Step 1 is set it equal to 0. Nate, what's step 2? What do you do next? For complete the square. Cancel the c. What's that? Sort of. Negative 8. How do you cancel it? Add it, and then leave a, exactly, leave a blank. So I'm going to add 8 to both sides. So you're canceling the c. What I mean is ax squared plus bx plus c. That's standard form. We're canceling the c, which in this case is negative 8, and leaving a blank behind. So negative 1x squared plus 6x plus blank equals 8. That was step 2. Somebody tell me step 3. Completing the square. Go. Undistribute the a. Is there one to undistribute? There is. Negative 1. After you pull out negative 1, what's left behind?
X squared plus negative 6x.
Good.
Plus blank.
Plus blank equals 8. The 8 doesn't change because it's on the other side. Fair right so far? Okay. Step 4. This is kind of the main step in complete the square. When it says complete the square, think binomial square, which is 3 steps. Go.
Generally, figure out what like square root.
Yeah, in other words, go back in time and find out what binomial square they used. What should be in front? Negative 1. Where did this come from?
X plus negative 6 or negative 3.
Yeah, I'll do x minus 3 just for old time's sake. Why 3? Why minus 3?
Because for a double product.
Right. Double the product, we're going to undouble it, which means cutting it in half. So what number should have been here? 9. Positive or negative? Positive. Any square is positive. To it. Take over Katie. There's extra weight here, the 9. How do I make up for it? Say again? Well, kind of, sort of. This is on the left side. You can do anything you want as long as you do it to both sides. Why is it negative? Yes. I think you just said it, but yeah. This is going to sound stupid, but it's negative 1 times bigger than we thought it was, which is really negative 9. Okay, you have to do the exact same thing on the left and right sides. There's an extra 9, but it's really negative 9. So you have to add negative 9. What does that make, by the way? Negative 1. Have you heard it so far? Step 5 has 2 options. If you want to solve, or if you want to graph. If you want to solve, you can just stop and start solving, square rooting and solving for x. But if you want to graph, there's one more step. So remember. Go. Yeah. It started equal to 0. It's got to end equal to 0. So add 1 to both sides. Don't put it inside. Make sure it's outside. So negative 1 parentheses x minus 3 parentheses squared plus 1 equals 0. And how do you fix the final answer? If you want to graph it. How do you say I'm going to graph this in math speak? Y equals. Instead of equals 0, replace it with y equals. That is vertex form. Nick, can you tell me the vertex?
Negative, positive.
Positive 3 comma 1. The vertex is 3 comma 1. here and from here. H, K. Correct. So we've got two of our 5 pieces. Because let me tell you where to find the axis of symmetry. Yeah, yes.
Goes through the vertex.
It goes through the vertex. So what does that give us? 3. Did x equals 3 or y equals 3?
X.
X equals 3. Now, pretend you didn't know that. Pretend you know that the axis of symmetry runs over the vertex, but you don't know where it goes and what the equation is. I would actually recommend you graph this thing first. We have to do it anyway. Let me see. Randy, where's the vertex on this thing? Good, 3, 1. And what can you tell me about the height of this thing? Yeah. So is it opening up or opening down? It's opening down. Does that make sense? The height multiplier is -1, so it's opening down. Blaze, is the height taller, shorter, or normal height? Normal height. It just happens to be going down. So give me the pattern for that. Over 1, down 1. Over 2, down 4, etc. That's what you do here. Over 1, down 1. By the way, I just gave you something for free. Then over 2, down 4. And there's your graph. So first of all, you needed a graph anyway. So you got this. Check. We needed the axis of symmetry. You might be able to see it now. Mary, help me out with this. Where is the axis of symmetry? Is it running up, down, or left, right? Up, down. Whereabouts? Correct. So what's the equation? In other words, what's the equation of this line? X equals 3, correct. Reminder, if you have a horizontal line or a vertical line, it's going to be a very small boring equation like x equals 3 or y equals 2. Y equals 2 would be like here, horizontal. X equals 3, here. So we got the axis of symmetry. Okay. Can somebody find the x-intercepts? By the way, you got insanely lucky on this one. Back up. Where are the x-intercepts? You can actually look at the graph. At 4 and 2. Let's pretend, for the sake of argument, by the way, you're done. X equals 2, x equals 4. Pretend for the sake of argument that you did not know that. That the graph came upon, there were decimals or something. How do you find the x-intercepts in general? Yeah. Solve. Solve for x. You could use the quadratic formula, you could use algebra if you're lucky, you could use factoring if you're lucky, etc. Is that gonna make sense? Okay. This was the change to vertex form method. I do want to show you the alternate method on this one, which is actually rather fast. You could say or y equals -1x squared plus 6x plus -8. I want to see if we can get this into x-intercept form. So, Nick, take over. How do you get this thing in x-intercept form? Ed. Okay.
Well, I already know that x-intercept is 2 and 4.
True,
Okay.
but how do you get it in x-intercept form?
Can you factor it by grouping?
I liked the first word. Factor by grouping needs 4 terms.
It's where you add up and then multiply.
Yes, what's that called?
Magic, no.
Measure pair would work, although it takes longer. Go. That's unfoil. Unfoil is where you add up and multiply. Now, there is something you should check first. Ha, got it. Before you do unfoil. GCF. Is there a GCF? Yeah, if the first term is negative, you must pull a negative GCF out. So it looks like this. Y equals -1 parentheses, what would that be?
X squared.
Yeah, minus is fine. Minus 6x and then plus 8. Does that factor, Nick, take over? go ahead and do that. Negative 1, parentheses, parentheses.
X.
So x and x.
Plus 2. No,
Minus 2, and
plus 4. Oh, minus 4.
yeah, how come? Explain.
Well, they end up being positive.
End up being positive if you're multiplying.
Yeah.
And they add up to what?
Negative 6.
Right. Unfoil, if you remember, unfoil means 3, 2, 1. 3 terms, degree of 2, and a 1 in front. Which is true if you ignore this. So then you find out two numbers that add up to negative 6 and multiply to be 8, ta-da, ta-da. And there are your x-intercepts. Now, pretend you've done it this way. So the very first thing we found is the x-intercepts. We don't know anything else. How do you find the y-intercept? Refresh my memory. Hang on. 0 for x, correct. And they kind of did that over here. It'll be the exact same. I forgot where to put it. Whatever. Oh, I just sort of did it in our head. So yeah, plug in x equals 0, y-intercept. You got the x-intercepts, you got the y-intercept. How do you get the axis of symmetry? Austin.
The x on the vertex. Wait. Somebody just.
Assume we don't have the vertex yet. How do you find the axis of symmetry? All we know is the two x-intercepts. So here's the graph so far.
Find the average.
Yes, it's exactly halfway in between. So what would that be in this case? It has to be 3. So we know the axis of symmetry is x equals 3. The axis of symmetry is exactly halfway between the roots, always, as long as the roots exist. And as long as the x-intercepts exist. How do you find the vertex? Sam? Okay. The vertex is run over by what? Axis of symmetry. How far over is the axis of symmetry? 3. In other words, that's x equals 3. The vertex is going to be 3 comma something. How do you find the something? How do you find y? Second? Plug the 3 in for x. Go up to the original, plug in x equals 3. Let's find out. So negative 1 times 3 squared plus 6 times 3 minus 8. So this is going to be basically negative 9 plus 18 minus 8, which should be 1. So the vertex is 3 comma 1. And that's exactly right. And hopefully you can spot up here, either here or here, the height multiplier is negative 1. So it's over 1, down 1, over 2, down 4, etc. And that'll help you get your graph. Okay? Questions on that? There is one other way to find the x-intercepts. We were lucky enough to use algebra here because we had just completed the square. There's one other way to find the x-intercepts if you're in standard form. You can do algebra if you're lucky. You can factor if you're sort of lucky. You can complete the square if you don't mind completing the square. There's one more method. Solving means getting x by itself. And if you have ax squared plus bx plus c, what formula can you include? Yeah. The quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all divided by 2a. That purpose is to find the x-intercepts, or at least the solutions. Questions? Okay, so this is one of the longer problems on the test. So I cannot promise that the problem will factor nicely. It might or might not. If it factors nicely, then x-intercept form is pretty nice. If it does not factor nicely, then you might need to complete the square or use the quadratic formula. And I definitely won't promise that algebra will work. It might not. Everybody good at number 20? Kind of stuff? Next, question. Yeah.
I go with that.
Yeah. Any other ones where you got stuck? How you on graphing the four forms of a line? Pretty comfy on those? Slope intercept form, standard, point slope, intercept form. Make sure you're secure on those. Go.
For 12 through 15,
Yeah.
you still want us, do you want us to do the form where you have I on the end?
Correct. Yeah. The he's asking about when you have an I in part of your answer. Like if you have like 3/4 plus 5i over 4, what I would like you to write it as is 3/4 plus 5/4 I. Yeah, I would like the I at the end of the second term. So just yank it off. Just sounds gross, but pluck the I out and put it. Yeah.
So for 14, would it be 1 over 4?
Oh heavens, yes, thank you. The computer doesn't know our rule. I let the computer do it on its own and I shouldn't. Naughty computer. Number 14, if you could write this in, it should be 1/2 plus 1 over 4 times I. They have I over 4, which is not technically wrong, but it's not simplified. A good catch. Yeah.
I was curious, like there's no force E where you like split it into two fractions, but then.
And it used to be 2 over 4 plus 1i over 4.
And then, number 19, it left it as 1, so it's like.
Yes. I think the reason, I sort of agree, sort of disagree with number 19. Because the quadratic formula does spit out answers looking like that. I am thrilled when people do -5 over 9 plus radical 43 over 9.
Okay, yeah.
Yeah. I will, just for the sake of argument, accept that. But I do want, if there's an I definitely want it at the end. So they're insisting it be an A plus BI form, and they're not insisting that non-imaginary numbers be that. Okay. I just a little curious. Next. Now's your game.
What would 7 be if it was
Don't tell me.
the slope intercept?
Oh, it's a little, oh, okay, no, I thought you were talking another I problem. Okay, slope intercept I'm good with. If you ever wanted to know, this is y minus 1 equals -11/5, parentheses x minus 1. If you want to know what the slope intercept form version is, distribute this. So y minus 1 equals -11/5 x plus 11/5. And I'm going to add 1 to both sides, which is adding 5/5. So you should have y equals -11/5 x plus 16/5. Which is a little gross, but it works. Okay. If you're right. Does that make sense? Do you want to see me work that otherwise? Now, again, this is far, far easier in point slope form. Point slope form is designed for things like this. They give you a point, they give you the slope, bam, bam, you're done. If you want to put it into it's -11/5. Oh, this is -11/5. Oh, I forgot. Ooh, bad. So again, and so this should be 6/5. Yeah, I forgot that. Was that an x plus 1 in the first place? Let me just look at it. That's my lesson. Don't do it without glasses. Yeah, it was plus in the first place. Okay. So yeah, this minus. Yeah, that should be fixed. -6/5. Is that better? Yeah.
I have my slope as just 11/5.
Oh.
Because I thought the opposite reciprocal of that was -5 over 11.
Okay. The reciprocal is -5 over 11. Oh, actually, let me try the original ones first. Does everybody have this? Yeah, speak now or forever hold your peace. And not pronounce you. Kidding. Oops.
It's okay, it was their guess.
Sorry.
He puts it when you want it.
Sorry, Mr. Blaine. My bad. Okay, let me get a new marker. Here are the 2 points. Oh, nice marker. 10 comma negative 4 and negative 12 comma 6. This is point A and this is point B. So the slope of AB, y'all, I'm going to do 6 minus negative 4 over negative 12 minus 10. So y2 minus y1, blah, blah, blah. 10 over negative 22. So it's negative 5 over 11. Does that make sense? Right? So that's the original slope. The perpendicular slope, you flip it upside down and then switch the sign. The opposite, the reciprocal is just negative 11 over 5. The opposite reciprocal is positive 11 over 5. Now, wait. Did I copy down something wrong here? 10 negative 4, negative 12, 6. Computer, what the heck? Yeah, you're right. Yeah, it's supposed to be positive 11 fifths. Are you serious? I'll write a nasty little, well, no. I'm going to write a very firmly worded note to the company here. Number 7, please change the slope to positive 11 over 5. Wow, that's very, let me check the, I want to make sure they get the point, midpoint right. It should be 10 plus negative 12 over 2, and then negative 4 plus 6 over 2. This should be negative 2 over 2, which is negative 1. And then positive 2 over 2, which is 1. Okay. That at least looks good. Yeah.
So then slope-intercept form, it would be y equals 11 over 5, x plus 6 over 5?
Let me double check. Here's the point slope form. Y minus 1 equals 11 over 5, parentheses x minus negative 1, or plus 1. No? A little less fuss. Distribute this to let 1 minus 1 equals 11 fifths x. Gentlemen, I can still hear you. Honest. And then add 1. It's sort of like the photo negative of what I first said, before I thought I was wrong. Plus, this is 16 fifths. That should be. Okay, good to know. Any other mangled parts of the answer key? Awesome to discover. Let me put a note on that so I'll just change that back in. Anything else? Any other questions? Okay, well, think about it for a second. I'll come back to that. I want to give you the optional method. I touched on this last year. Some people remembered this. Let me put it here. If you have something in standard form, you know I said there were 2 methods. Get it into slope-intercept, or what am I saying? Get it into vertex form, or get it into x-intercept form. There is another way. If you have y equals ax squared plus bx plus c, there is a formula. No, can you put it away, please? Yeah, toss it if you reduce it. There's a formula for the axis of symmetry. Anybody remember what it is? It's x equals something. If it's in standard form, there is an automatic formula for the x, and it has something to do with the quadratic formula. Yeah. That's not the discriminant, good guess. It's the first half of the quadratic formula. Negative b over 2a. That will automatically give you the axis of symmetry, and it'll automatically give you the first number in your vertex. So if I gave you, just hypothetically, y equals, should I give you the same one or a different one? Okay. Different one? Okay, I'll just make this one up. So 2x squared plus 10x plus 8. If I want to find the axis of symmetry, it's x equals negative 10 over 2 times 2, which in this case is negative 10 over 4, which is negative 5 halves. Now that's a kind of an awkward vertex, but I know the vertex is now negative 5 halves, comma, something. And then you just plug this into the original in order to get the y. I mean, this one's gross, so I'm not going to do that to you on the test. It'll be a round number. I hope. Yeah, I probably. But if you want to do that, you are welcome to do that. So the axis of symmetry is this, and then the vertex is basically the axis, comma, plug in the axis. Okay. So you can do everything in standard form if you want. You'd have to remember this formula. X equals negative b over 2a. Then for the x-intercepts, you can just use the quadratic formula. For the y-intercept, it's easy, it's just c, and then sketch the graph. I would say get the vertex first, use the height multiplier, get the right pattern, and you're done. Okay? You do not have to use this on the test, but you are welcome to. If you find it helpful, by all means. Questions? Any others? So let me just quick skim through this. Everybody's okay. If I give you 2 points, you can give me the equation through the 2 points. Is anybody like completely emotionally attached to slope-intercept formula and would like to see the direct way to get those without going through point slope first? I think this is sort of what you're doing. Do I see it? It is possible. I'm just going to make up 2 points. Let's just say point A is 2, 3, and point B is 6, I don't know. -7. Try that. So I want to find the line through these 2. First thing I need to find is the slope. So it's -7 minus 3 over 6 minus 2. -10 over 4, which is -5 halves. All I really need to make a line is a slope and a point. And you can pick whichever point you want. I like this one. This gives us nice. So it's y minus 3 equals -5 halves, parentheses x minus 2. So that's the point slope form method. And it's relatively fast. Okay, yes, you're right. If somebody wants to do it directly through slope-intercept form, start with the formula, y equals mx plus b. You'll have to find the slope, but plug that in right away. And pick your point. Instead of using point slope, which actually would save you a step, call this x and call this y. And then just temporarily plug them in. So it's 3 equals -5 halves times 2 plus b. Okay. These 2's cancel, so 3 equals -5 plus b. Add 5 to both sides. And b is equal to 8. You just found your y-intercept. So the final answer for this is y equals -5 halves x plus 8. Is that gonna make sense? In every single form, if you have missing stuff, plug in what you have. And chances are that'll sort of almost magically give you what you need. Does that make sense? Follow how I did that? Any other questions on the come on. So you can find a perpendicular bisector equation. Everybody's good at graphing 4 forms of a line. You can add, subtract, multiply, and divide complex numbers, including splitting them apart like number 14 kind of didn't. I apologize on behalf of the silly computer again. Square rooting, how many answers in a square root? 2, yes. I would like this to be the first test where nobody loses points for that one. So please make sure you have 2 answers for a square root, 1 positive, 1 negative.
For that one, do you want us to write 2 radical 13 and then negative 2 radical 13, or can we just leave plus or minus 2 radical?
This one I'd be okay with plus or minus 2 radical 13, as long as there's no confusion. And they forgot to write it, but I would like P equals plus or minus. So I have P equals 10. I probably wouldn't mark it wrong, but I'd probably put a frowny face next to it, which could scar you for life. Number 17, solve by factoring. What do you have to do in number 17 first? What has to happen in number 17 first before you even do it? Go.
Set it equal to 0.
Set it equal to 0. The zero product property only works if it's equal to 0. Right? You can't, there's no such thing as a 40p minus 32 product property. Number 18, solve by completing the square. Guess what we have to do first there? Yeah. Set it equal to 0. Anytime you solve anything, it's pretty much set it equal to 0. Number 19, solve with the quadratic formula. At the risk of being a broken record. Set it equal to 0. Number 20 we went over. Would anybody like to see the extra credits worked? Yeah. All right, any particular one?
Number 22.
22, yeah, I expected that one. An altitude is basically a height. It's a line segment connecting one corner of a triangle vertex to the opposite side perpendicularly. That's a word. Let's try it. So we've got point A is 1, 4. Point B is 9, this. And then point C is 11, -2. This is one of those rare times I would actually recommend you graph it. 1, 4. Nine. 6. 11, -2. And I would connect them, make a triangle. It says, give the equation for any of the 3 altitudes. I'll let you pick. Do you want an altitude coming from A, coming from B, or coming from C? Totally up to you. Go. B? Okay. I'm going to draw it just so you're aware. So this is the perpendicular bisector. Or, sorry, it's the altitude. Not the bisector. I want the equation of that. In order to get an equation of a line, you need 2 things, at least. Yeah. Go. A point and a slope. Do we have a point? Yes, we're actually half done. We've got 6, -7. That'll be part of your answer. All I need is the slope. Somebody tell me how to find that slope. I only have 1 point, yeah.
Like find the slope between A and C.
Okay.
The line and then make it the perpendicular.
Right, if you notice it's perpendicular, take the opposite reciprocal slope and you'll be done. Can somebody give me the slope between A and C? Like, set it up for me in formula-wise. I can help you. Like, from here to here. -2 over 1 minus 11, is that? Okay, calculate. 6 over -10, which is, yeah, 3 over -5 or -3/5. That's the slope for the bottom. What's the slope, Katie, that we want? Yeah, I can. This is the slope of the bottom. I want to get the slope of the altitude.
So we need the slope between B and the midpoint.
It's not going to the midpoint. The midpoint's actually a little bit further to the right. But I need a particular slope. And I need a perpendicular. How do you get perpendicular? Opposite what? Reciprocal. What's the opposite reciprocal of that? Correct. The perpendicular slope is 5/3. So can somebody give me the final answer going through point B, and you've got your new slope. New point slope would be good.
So that's y minus 6.
That's the x. It's y minus y1. You give me x1.
So y minus -7.
Y minus -7 equals 5 over 3.
And x minus 6.
Got it. That's it. So you can do y plus 7 if you must. Okay. Question. What? I just noticed that's not any of the answers in there. Oh, wait a minute, is this 1, 4, 9, 6, yeah. 11, -2. What the heck? Why did I write 6, -7? I'm going insane. That was my fault. That wasn't, was that on my version? Funny. That was right. Now, hang on a second. What's that? I have no explanation for that except stupidity. That was incredible. Wow. I don't know what the heck happened here, but oh, now you come on. What? Wow, that was incredibly stupid. Hang on a second. Tell you what, let me turbo this. We've got 10 minutes, I can do it. 2, 3, what's the real one? I was looking at the wrong version. Yeah. I had a version 2, and this is version 3. All right, at least I'm not hallucinating level crazy, just spaced out. And then we did AC. All right. So yeah, 1 and 4. We still have the slope of -6 over 10, which is -3. But so this is fine. So yeah, we just need B. This is supposed to be 1 and Josh, oh my goodness, I owe you an incredible apology. You were doing the right one, and I was off in La La Land doing I don't know what. But yeah, okay. I feel better, and that's actually on the enter key, so that makes you feel doubly better. That's the second of the 3 formulas. Y minus 6 equals 5/3 parentheses x minus 9. Phew! I've rarely had a point problem. Wow. That was incredible. I do have to tell you a 30-second story. If people sometimes think that, wow, you teach pre-calc, you teach calculus, you must be infallible. Funny. So, calculus, my worst time ever. Calculus problems can sometimes take 30 or 40 minutes to do one problem. I picked one of those to demonstrate in class. We were doing, the entire homework was 2 problems, problem 1 and problem 2. Not complicated. I mean, the problems were complicated, but that was pretty straightforward. The homework assignment was problem 1, problem 2. I spent the first half of the hour writing down the work for problem 1. And then somehow, I don't know how, I had both of the answers written out on my guide sheet. And then I spent the next 25 minutes writing out the second half of the answer to problem 2. Now, they have absolutely nothing to do with each other, but they had the same variables, so I didn't notice until the end of the hour. And then I came up with this answer that was insane. And it's just like 55 minutes of my life just flushed down the sewer or something. But that was even worse. It's like everything I know is a lie. Like what just happened? And then after about 3 minutes later, I said, please don't kill me. And they're all, yeah, you can imagine their facial expressions at this point. And they were exhausted. This is like 5th hour. It's kind of like almost now. But it's like 5th period and end of the day, and everybody was just kind of half fatigued and half like, and they was just saying, we're taking you on faith, Mr. Cotton. We're doing this. And it was a disaster. So I had to do the entire thing over the next day. So that was my shining glory. So, no, I'm not a fellow. QED. Any other questions you want to see word comments? Hopefully I'll do it right. That was extra credit 22. 21, you can still complete the square. Just be aware, you're going to get fractions in your parentheses, which is perfectly okay. It won't hurt anybody. And then number 23, you can complete the square. By the way, number 23, get y by itself first. Number 23, hint, get y by itself first. Then just complete the square or do whatever method you like that. It should be relatively friendly too. The x-intercepts are nice. You shouldn't have any horrible fractions, even if you try and, I think it factors too. But get y by itself first. So you will temporarily have fractions, but it will it'll work itself out. Anything else? Going once, twice. Mary Claire, it just occurred to me that this is going to be totally surreal watching this at home. So you can probably fast forward over my stupid mistake there, and I won't mind. So, any other questions? Going once, twice. All right, test tomorrow. Everybody up for it? Test tomorrow. All right, that'll do it. Just take about 3 or 4 minutes, let your brains cool off. Yeah. Who put the leaves up? That was Mrs. Black. Yes. So this is my hand waving bye. So bye-bye.